Hello everyone, this is Shashank Kothari and today I am going to present my presentation on IoT and M2M. So what are we going to cover in this presentation is first of all introduction to M2M, then differences and similarities between M2M and IoT, then we're going to discuss about software defined networks, then we will discuss about NFVs and then differences between SDN and NFV. So introduction to M2M. Machine to machine refers to networking of machines or devices for the purpose of remote monitoring and control and data exchange. An M2M area network comprises of machines or M2M nodes which have embedded hardware modules for sensing, actuation and communication. Various communication protocols can be used for M2M local area. Networks such as Zigbee, Bluetooth, Modbus, M-Bus, wireless M-Bus, power line communication, etc. So, the communication network provides connectivity to remote M2M area network. The communication network can use either wired or wireless networks which are IP based. While the M2M area networks use either proprietary or non-IP based communication protocols, the communication network uses IP based networks. So as the figure shows, M2M have basically three primary domains which are M2M area domain, network domain and application domain. The M2M devices can connect to the M2M service platform directly through a wide area network which is also a connection, for example cellular, 3G, 4G or an M2M gateway aggregation point. The M2M gateway collects and processes data from simpler M2M devices which are in M2M area domain, as we can see in the first domain, and then manages their configuration and operation. Also, it ensures the M2M devices interoperate with and are interconnected with the communication network. The M2M devices and M2M gateway are comprised of an M2M area network which provides connectivity among them. Typically, the use of an M2M area network is preferred when the cost, power or location of the M2M devices is decided factor. So in this case, several wireless and personal area networks technologies such as Wi-Fi, Zigbee and Bluetooth can be adopted through which these devices can communicate. Then the network domain includes the core and access networks, and then here comes the application domain. The application domain contains the M2M specific business processing engines. M2M gateway. Since non-IP based protocols are used within M2M area networks, the M2M nodes within one network cannot communicate with nodes in an external network. To enable the communication between remote M2M area network and M2M gateways are used. So M2M gateways are used. Now M2M gateway consists of virtual nodes which are native protocol, translation and proxy. Now these nodes can't communicate to M2M area domain, to the network domain by itself, so there is a need of gateway, and these gateway consist of virtual nodes which uses IP routing for communication. So then differences between IoT and M2M. So communication protocols. M2M and IoT can differ in how the communication between the machines or devices happens. M2M uses either proprietary or non-IP based communication protocols for communication within the M2M area networks. Machines in M2M versus things in IoT. So the things in IoT refers to the physical objects that have unique identifiers and can sense and communicate with the external environment and user applications or their internal physical states. M2M systems, in contrast to IoT, typically have homogeneous machine types within an M2M area network. Hardware versus software emphasis in IoT versus M2M. While the emphasis of M2M is more on hardware with embedded modules, the emphasis of IoT is more on software. Data collection and analysis. M2M data is collected in print solutions and point solutions and often in on-premises storage infrastructure. In contrast to M2M, the data is in IoT is collected in the cloud, which can be public, private or hybrid cloud applications. So M2M data is collected in point solutions and can be accessed by on-premises applications such as diagnosis applications, service management applications and on-premises enterprise applications. IoT data is collected in the cloud and can be accessed by cloud applications such as analytics, application, etc. So this is the figure which shows us the communication in IoT versus M2M. The biggest difference between M2M and IoT is that an M2M system uses point-to-point communication, and an IoT system meanwhile typically situates its devices within a global cloud network that allows larger scale integration and more sophisticated applications. So this figure shows us how M2M communicates and how IoT communicates. So M2M works by connecting sensor data and transmitting it to a network, as machine to machine communication uses public access networks like Ethernet or Wi-Fi in the link layer, which is as shown in the figure. Link layer, the primary applications of M2M had to do with telemetrics, pioneering telephonic companies that started using telephone lines and radio waves to transmit the signal. Later, the technology was adopted by manufacturing, healthcare, finance, and other industries. And the M2M point-to-point connection uses network layer and link layer for its communication. Now, while M2M enables device-to-device communication, the Internet of Things allows multiple machines to design a connected data network. So, as IoT is a software-based, its operating mode is similar to that of SCADA, a principle of remote monitoring system that transmits data from a device into a program and presents it in the form of insights. The Internet of Things has a broader range of applications than M2M and allows users to have a better control over gathered data, and IoT includes of application layer and transport layer. Application layer, which has HTTP, XMPP, MQTT, different protocols to communicate within devices, and the TCP and UDP easily transports helps in transporting the communication. Software defined network. Software defined networking is a networking architecture that separates the control plane from the data plane and centralizes the network controller. Software-based SDN controllers maintain a unified view of the network and make configuration, management, and provisioning simpler. The underlying infrastructure is in SDN uses simple packet forwarding hardware as opposed to specialized hardware in conventional networks, as shown in the figure, which consists of application layer, control layer, and infrastructure layer. Application layer, which has network application and then connected with open API, which is a not bound, and then control layer has network operating systems. Then the southbound open API, which enables open flow, and then there comes the infrastructure, which has simple packet forwarding hardware. Key elements of SDN: centralized network controller. With decoupled controller and data planes and centralized network controller, the network administrators can rapidly configure the network. Programmable open APIs. SDN architecture supports programmable open APIs for interface between the SDN application and control layers. Standard communication interface open and OpenFlow. SDN architecture uses standard communication interface between the control and infrastructure layers. OpenFlow, which is defined by the Open Networking Foundation, is broadly accepted SDN protocol for the southbound interference. Now, network function virtualization. Network function virtualization is a technology that leverages virtualization to consolidate the heterogeneous network devices into industry standard high volume servers, switches, and storage. NFV is a complementary to SDN, as NFV can provide the infrastructure on SDN on which SDN can run. The figure shows us the architecture of virtual network functions with the network function virtualization. So here, virtualized network function is a software implementation of a network function which is capable of running over the NFV infrastructure. NFV infrastructure includes computer network and storage resources that are virtualized. NFV management and orchestration. Management and orchestration focus on all virtualization specific management tasks and covers the orchestration and life cycle management of physical and or software resources that support the infrastructure virtualization and the life cycle management of VNF. NFV's use case. NFV can be used to virtualize the home gateway. The NFV infrastructure in the cloud hosts a virtualized home gateway as shown in the figure, which has home network and a public network. The virtualized gateway provides private IP address to the devices in the home. The virtualized gateway also connects to the network such as VoIP and IPTV, which is in the figure shown below. Now, differences between SDN and NFV. Software-defined networking seeks to separate network control functions from network forwarding functions. It controls and orchestrates networking functions for specific use. It abstracts physical networking resources, switches, routers, and so on, and is standard based and vendor neutral. So, differences NFV. NFV seeks to abstract network forwarding and other networking functions from the hardware on which it runs. It provides basic networking functions. NFVs aim to virtualize all physical network resources beneath a hypervisor. NFV is an industry initiative originated from telecom and industry players. Thank you.